Hi everybody, welcome back to Physics Screencasts. Today what we're going to be doing is talking about problems that involve motion, and we're actually going to be talking a fair amount right now about one of the key survival strategies that you want to use as a person who's solving physics problems. Because of the fact that physics problems involve lots of information, or can involve lots of information, they can involve math, and there can be more than one right way to go about solving physics problems. Physics has a reputation as being a tough subject, and that's really fair. As someone who's done a lot of physics, I can speak for the other physics teachers at the school as well by saying that we get it when students sometimes struggle with how do I keep myself going forward? How do I start? And so what we do is we, like a lot of science people, we like silly acronyms for stuff. And there's one that a lot of the physics teachers will talk about called LEPS, which only means something if you have been in class and you get what these different words actually stand for. What we think this means is one step at a time survival strategy for how you deal with the problems that you're going to encounter when you are confused. The first thing we're going to suggest that you do is if you read a problem and you don't understand it immediately, that's fine, that happens, but what you want to do is make a list of the information that's given in the problem. And a lot of times that list is going to be guided by the fact that you might know something about the topic that you're into, so you might have a clue what equation it is that you might want to think about using. And then if you do the first two steps correctly, you're going to be able to plug into your equation you're going to solve. So that's a super fast run through, but what we're going to do is I'll take my time and go through a couple of examples and you'll see what I mean. So hang in there. So in this example we've got Sandy the sloth cruising across a roadway, which is probably a bad idea. But anyway, Sandy's headed down to Nick's Giovanni's and is, I don't know, who knows why. But anyway, we know that motion is happening. So as happens a lot of times, I get a physics problem and I get a story. It looks to me like the physics problem actually starts right around here, and the rest of the stuff is this kind of information from my brain. I pick out a number, and it looks like 54 centimeters per second. So I am being guided by my equation a little bit, but my list is going to include D, a V, and a T, since we're into this topic that involves motion. And when I see something like 54 centimeters per second, I know that that is a velocity. Now, you're going to notice I wrote that fraction with a clear top and a clear bottom. T, let's put an equal sign. D, I'll put an equal sign, and I'll go hunting for the next piece of information. How long will it take him to cross a road that's 12 meters wide? It looks to me like 12 meters is going to fit right there, and T is the question mark. And that's all it takes. So list is done. It's got labels on it. It's got a variable, and if I have just one question mark, that's probably a good thing. The next step we're going to do is to cruise on down to the equation part of LEPS, and I know from the motion formula that D equals VT, and the equation part of this process is where I think about algebra for a minute, and what I know from the list part is that I want to get T by himself. So what I'm going to do right now is divide both sides by V and isolate this guy right here. So when I divide both sides by V, I'm going to end up with D over V equals T. So I'm feeling good about that. So first two steps are out of the way. I'm in the home stretch. The plug-in part is pretty straightforward. I go right back to my list and I check and I say 12 meters over, wait a second, I've got a problem. Because I plugged in using labels, I can see this headache already happening before I get this problem wrong. The good thing about doing a list is that it gives me room to work. So normally I'm going to work down a paper and not all squashed into an iPad screen, but when I have 54 centimeters per second, what I'm going to do is create a little factor label and I'm going to go and write centimeters and meters, and I'm going to remember that one of the big ones equals a lot of the little ones, and I'm going to create space and end up with 0.454 centimeters per second as being the speed of my sloth buddy. So then when I go back to my equation, d over v equals t, I'm going to plug in with labels that are compatible with each other. So meters over meters is something that I can do, or meters over centimeters gets me in trouble, and that'll equals t. And when I go ahead and work that whole arrangement out, I'm going to end up with t equals 22.2 seconds, and there you have it. That's how LEPS works in real life. There you go. One more and we're out. So in this question, we don't get much of a story. We get mostly just math. It looks like we're being told that this guy is going to crawl all the way down from campus to Nick's Giovanni's, and they give us a distance of 1 kilometer, and that's all they give us. So it sounds, based on that, like they definitely are looking for how long. And if I go back to my list, D, V, and T, I know that the D is 1 kilometer. And I know that they're looking for the T, so they must mean that we're supposed to know what the V is, and that probably means that we're just going to grab the velocity from the last problem. And I had a little bit of math going on last time, if you remember. In the process of solving that problem, we had 54 centimeters per second, and we had converted that into 0.54 meters per second. So I think it's fair if we just reuse that information and see what it gets us. So anyway, that looks like a good list. We'll go into the equation part, and no need to reinvent the wheel. This problem's exactly the same as the last one. So the algebra that we did said T equals D over V. And I'm going to write down 1 kilometer, and oh, wait a second. It's happening again, like it always does. I've got 0.54 meters per second, and I've got 1 kilometer on the top, and those aren't going to be compatible. So what I'm going to do is run back up to my list right here, and I do this 2 different ways, and I get caught between them. So I'm going to write the bars with the conversion line between them, and I'm going to go and do a little conversion. I'm going to do kilometers on the bottom and meters on the top. I know that 1 kilometer is the big thing, and that it's going to equal 1,000 meters. So I'm actually just going to do a substitute here, because I know that I've got 1 kilometer is the same thing as 1,000 meters, and now I've got an equation that I can actually plug in and solve, because I've got labels that can cancel out against each other. And when I go through and do that problem, I'm going to end up with the sloth taking a long time to get where he's going. Namely, that works out to 1,852, give or take, seconds, which doesn't seem so bad until you convert it into minutes, and you realize that I'm going to use my about equal symbol. That equals about 31 minutes, and that's assuming that that Sandy doesn't get tired or have to take a break or anything like that, or get run over by people that drive up Spring Street. So anyway, that's how LEPS works for constant motion problems. You're going to hear us use it a lot. So take care. Have a good day. Bye-bye.